All right, so let me just review with you some details about the test before we get started on your review. So, for our Chapter 5 test on analytical trig, looking at Wednesday for first, third, and fifth period, and on Thursday for sixth period. So, our targets that we're covering, so solving trig equations, sum and difference identities, verifying identities, and then the stuff we started the chapter with, composite trig functions, inverse trig functions, and regular trig functions. All that's just solving. So remember, you can use both of your identity sheets, both on the test and right now while you do the review. You can use your calculator, I would say, when it's appropriate. So that's really only going to be with trig equations when it requires a calculator. Besides that, your calculator is not going to give you the exact values you want, so I wouldn't use it. So keep that in mind. So just make sure that you have those sheets ready, that when you are getting ready for your test that day for class, that you have a whiteboard to work on if you want to take pictures and not work right informative. All right. Remember also that I have office hours every day from 12:30 to 1, so feel free to stop by. All right, we're going to do what we did for the last review. So I want you to try each problem, and then you will see me work through it and see my solution. All right, first problem. I want you to verify this identity. Pick which side. Remember, you're allowed to use your identity sheets. So pick which side you want to start with and go for it. All right, so let me show you both sides, really kind of where you decided to start from. And I feel like it makes a difference that I'm letting you use your identity sheet that maybe more of you thought to do the way on the left. But I would say my preferred method is I looked at the right hand side and thought, okay, there is a plus sign. I want to bring everything together. So, first thing I did was change them to sines and cosines. Then I did the math here. I multiplied, right? If I multiply, I get cosine over sine squared. Then I'm trying to add. To add, I need a common denominator, right? To multiply, we don't need a common denominator. We had sine and we got sine squared, okay? But to add, we need a common denominator. So we give the first fraction a sine squared in the top and bottom, second fraction a cosine in the top and bottom. Then what do we have? We have sine squared plus cosine squared over sine squared times cosine. Sine squared plus cosine squared is 1. 1 over sine squared is our cosecant squared. 1 over cosine is secant. Okay, if you went with the left-hand side, you were looking at something that was multiplied and you wanted to divide it up into addition. So that's where Pythagorean identity comes in. Cosecant squared is the same as 1 plus cotangent squared. Okay, then we multiply it by that secant that was there originally. We distribute it out. What do we get? We get secant plus cotangent squared times secant. Then we have to deal with what we have. So secant is 1 over cosine. Cotangent squared is cosine squared over sine squared times 1 over cosine. One of those cosines can cancel. We have cosine over sine squared. When you think about splitting that up, that is cosine over sine times 1 over sine, which gives us what we needed, right? All right, next one. Find the exact value. All right, so I'm going to ask you to try all 5 of these problems. All right, so I want you to try all 5 of these, and then I'll go through my solutions. All right, so first one, cosine of pi over 4 is root 2 over 2. My hope is that you just know that, but if you don't remember, you can always draw your triangle with the 1, 1, root 2. And we're basing this off of Sir-Sixertix, where sine is the y over the r, cosine is the x over the r, and tangent is the y over the x. For cotangent of negative 210 degrees, I feel like you probably need to draw that one. You draw it, you get a 30-degree angle for your reference angle. So I'm a 1, 2 with a negative square root of 3. And then since tangent is my y over my x, cotangent is my x over my y. Negative root 3 over 1 is just negative root 3. Once I see an inverse function, I'm going backwards. I'm saying cosine of what angle gives me this value? This is the ratio, x over r. Where can my x be 1 and my r be 1? That happens at 0. So that is angle 0. 0 degrees, 0 radians, they are the same thing. For the fourth problem, we're looking at starting on the inside, working our way out. Inverse sine says, hey, that's the y over the r. So I draw an inverse sine is negative in the fourth quadrant. So just a reminder that we have all our inverse functions are positive in the first quadrant. Cosine goes to the second quadrant to get negative because it relies on the x's. And sine and tangent both go to the fourth to get negative. Nobody with our inverses uses the third quadrant. So once we draw it in the fourth quadrant, because it's negative, we don't know the angle. Inverse sine is asking for the angle. We don't know it, but we can find tangent of whatever this theta is. Tangent is Sir Sixertix, the y over the x, so negative 3/4. And then for our last one, we start on the inside again. This is a regular sine of 2/3. So I just drew 2/3. It was a 60-degree reference angle. I have my y over my r, so I got √3/2. You can see that here. And I'm still doing inverse sine of that. Sine of what angle gives me this value? That's my y over my r. I redrew it only to show you that it is in the first quadrant, because although we know regular sine is positive in the first and second quadrant, inverse sine is not defined in the second quadrant. So we go first quadrant, we draw a triangle, and that angle is pi/3. All right, next up. Oh, here we go. Solve that equation. We're going, all of the equations are going to be looking for specific solutions from 0 to 2 pi. So go ahead and solve this equation, which says sine of 2x equals √2/2. All right, hopefully you noticed that 2 is what was going to give us lots of answers. So first, we had to draw this out probably. We had to look, where is sine going to be positive? Sine is positive in the first and second quadrant with a 1, 1√2. So that gave me pi/4 for the first quadrant and 3 pi/4 for the second quadrant. I put plus 2 pi n because it's sine. Remember, sine and cosine as well as secant and cosecant would use 2 pi, whereas tangent and cotangent use 1 pi. Right? That is what 2x equals. I have to divide through. So what do I get? I get pi/8 plus pi n. Remember, you have to divide all the way through by 2. And then I get 3 pi/8 plus pi n. So pi/8 is an answer in my list. To add pi, I make a common denominator, give it an 8 in the top and bottom. 1 plus 8 gives me 9. If I did 9 plus 8, I would get 17, and that's too big. Remember, we can only go up to 2 pi. And in eighths, that would be 16 pi/8. So then I come over here to my second answer set. 3 pi/8 is an answer. I add 8, I get 11. If I added 8 more, it would again be too big. All right, next up, we are using your sum and difference identity sheet. This is going to be your special identity sheet. So just a hint, in case you have trouble getting started here, you want to draw a picture based on the given. So draw a picture that has alpha and beta, and then you're going to go ahead and evaluate cosine of alpha minus beta. All right, so first thing I did here was draw my pictures. It says that alpha is in quadrant 2. I knew my y and my r, so I could label that my x was -4. Be careful that you get that negative since it's in quadrant 2. For b, it says it's in quadrant 3. We know cosine is my x over my r. I label my x and my r. I find my y, or I know it. I make sure it's negative because I'm in quadrant 3. Once I expand with the formula, remember you can never just distribute there, so you have to expand with the formula. Then I'm doing each one. What is cosine of alpha? Well, I go here, I do my x over my r. I was not pointing at the r, sorry. -4/5. Then what's cosine of beta? X over r, -12/13. Sine of alpha, the y over the r is 3/5. Sine of beta is the y over the r, and I get -5/13. Okay. From there, I'm just multiplying, multiplying, and then I add together and I get my final answer of 33/65. All right. I didn't write all my work out there, but the negative and negative makes a positive. So that's positive 48/65. 3 times -5 is -15/65. And that's how I subtract and get the 33/65. All right, next one. Here we go, another equation to solve. Remember our tips for solving equations. You want to try, what's easier first. So I would say try factoring first. If you can't factor, you have to go to quadratic formula. So try it out and see if you can get all your solutions. Right, so for this one, I could factor, you could factor. So over here, I did my scratch work where I factored with a leading coefficient. I got x minus 3 and 3x plus 1. So I brought it back here. I said, all right, so cosine x minus 3 and 3 cosine x plus 1. Set them both equal to 0. I get cosine of x is 3. Cosine of x is negative 1/3. Now, cosine of x cannot equal 3. All right. If you make that 3 over 1, my x and my r, can the x be 3 and the r be 1? No, it can't. That leg can't be bigger than the hypotenuse. So that one's out. Also, if you did that in your calculator, inverse cosine, it would say undefined. Okay. Make sure, that you try to solve them by hand first, because if you can get an exact value, you need to. So then we look at the negative 1/3. It's not undefined, but you do have to use the calculator. So in my calculator, I should have shown the step that said x equals inverse cosine of negative 1/3. I just wrote with my mouse. I'm sorry, that's not super pretty. All right, I'm just going to ask you to go to the hundredths here. I get that x is 1.91. All right, but I'm not done yet. I have to find my other answer. Remember, how do I remember around the circle? Well, this is pi. Pi is 3.14. Half of that is 1.59. So if I'm 1.91, I am past that. That's my first angle where cosine is negative. Cosine's also negative in the third quadrant. If I know that this is 1.91, two ways to go. Either I know this is 1.91, so I can do 2 pi minus that. I get the 4.37. Or I find the reference angle. I can do pi minus 1.91. I can get the reference angle of 1.23. I know the reference angle is the same, so then I do pi plus the 1.23 to get 4.37. And those are my two answers. All right, next up, verifying an identity. See what you can do working through this. Use your identity sheet if you need to, and see if you can make the one side equal the other. So here I went with changing everything to sines and cosines. So tangent is sine over cosine, cotangent is cosine over sine. I want it all to turn into a simple secant, so I made a common denominator. Gave this a sine in the top and bottom and a cosine. What happens? I have sine squared plus cosine squared over my common denominator over 1 over sine. Big deal there. Sine squared plus cosine squared is just 1. So I have 1 over sine x times cosine x. I flip my 1 over sine x because it's being divided. So it's sine x over 1. A sine cancels. 1 over cosine is secant. All right, next up, this looks nasty. Okay, right? And the directions would say evaluate. But you can use your sum and difference identity sheet and you can evaluate this. So do it. All right, so this fit the pattern of our tangent of alpha plus beta. So we do 65 plus 85 is 150. We draw 150. It's a 30-degree reference angle. We can do 1, 2, and a negative square root of 3. So Sir Sixer ticks the y over the x. 1 over negative 3 is negative root 3 over 3 is your final answer. Next up, sine of 75. Sine of 75. Again, I want you to think outside the box. You cannot solve this normally by hand, so go to your identity sheet and see what you can do to solve sine of 75. All right, so I can think about the fact that 75 is 45 plus 30. Then I'm using my formula sheet to say, hey, sine of alpha plus beta. I'm going to expand with the pattern. Sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. And then I'm going to solve each one. Be careful when you solve. If you need to draw a picture, draw a picture. Sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 30 is 1/2. I multiply these two, I get root 6 over 4. These two, I get root 2 over 4. Final answer, root 6 plus root 2 over 4. All right, solving another equation. Be careful, take your time, see if you can get all the solutions. All right, so I had to use an identity here. I noticed right away, and you have to notice they are different functions. If you just go to factor this and pretend like they're one thing, it won't work. It's not right at all because it doesn't work that way. You can't factor something out. So we use the identity. So I put in a 1 minus sine squared for cosine. I distributed through my -2 and combined like terms, made it look normal. This one I could factor. I didn't have to use quadratic formula because I could factor. So I factored it to 2 sine x plus 1 and sine x plus 2. The sine x equals -2. No, it doesn't, because sine is the y over the r, and the y can't be 2 with an r of 1. For sine of x equals -1/2, again, my y over my r. Sine is negative in the bottom two quadrants, right? So I go bottom two quadrants. If this is -1, my reference angle is 30. So that's my 7 pi over 6 and my 11 pi over 6 are my final answers. I feel like we've done enough of these. All right, if you want to try this one, go ahead. If you feel done, that's okay too. Here's my answer. It factors, and you can solve both of them. Final answer, 2 pi over 3, 4 pi over 3, and pi. Feel free to pause and check it out. All right, so that is the end of those practice problems. So here's what I would suggest you doing. Your test is next class. So to study for math means to practice. So your review problems are online on the Pearson site. Remember, it tells you if you're right or wrong. I put lots of problems so that you could do lots of practice. So do as much practice as you want. Go through, your notes, your old homeworks, with those, verifying identities. Make sure you re-practice the ones we already did. You could do the same thing for the trig equations because then you know if you're right or you're wrong. You're not going to remember all the answers. So that's another great way to practice. Remember, I have office hours if you need extra help, but just make sure that you are practicing so that you are ready. Have a great day.